question number 16, a monochromatic light of wavelength lambda naught is incident on two identical metal spheres having work function phi naught and 2 phi naught respectively. Intensity of light on each of the sphere is I naught. After some time T1 and T2, the emission of photoelectron stops on the spheres respectively. After that, they are connected by a metal wire and they achieve common potential V after charge Q flows through wire. Physical quantities are mentioned in column 1 and their dependence on different quantities are mentioned in column 2. So let's analyze the situation. Suppose these are two metal spheres and both are identical, so their radii are same. The work function of first sphere is phi naught and that of second sphere is 2 phi naught. The intensity of light falling on each sphere is same, that is I naught. So suppose after time T1, due to the photoelectric emission, the charge Q1 appears on the surface of first sphere and the photoelectric process and the phenomena of photoelectric emission will stop. Similarly, after time T2, the charge appearing on the second sphere is Q2 and at that moment further emission of photoelectrons stops. So if I calculate, let at these instants the potential appearing on sphere 1 is V1 and the potential appearing on sphere 2 is V2. Then on applying photoelectric equation, we can find out the value of V1 and V2. Suppose lambda naught, it is given in the question that the wavelength of light is lambda naught. So Sc by lambda naught is the intensity of incident photon on the metal. Let on the first sphere work function is phi naught, then this is the maximum kinetic energy available to the ejected photoelectron. And in this process, this metallic sphere gets charged. So if I assume let V1 is the final potential which is appearing on this surface, then if this potential is appeared on the surface of the metallic sphere, then further emission of photoelectron is not possible. So I can equate this is equal to E into V1. So from here I get the value of V1. So it is equal to Sc by lambda naught minus phi naught divided by E. In the similar fashion, I can write the value of V2. So it is equal to Sc by lambda naught minus 2 phi naught, it is phi naught divided by E. Now analyze the option A of column 1. So T1 is the time in which further emission of photoelectron stops. At that moment the potential on the surface of metallic sphere is V1 and charge on it is Q1. Now we have to check on what factors this T1 depends. So if I check the entries of column 2, dependent on intensity I naught, it is correct because as more number of photons are falling on the metallic surface, the time will get reduced. So P is the correct matching. Then dependent on the work function phi naught, so therefore we are getting 2 times T1 and T2 for the same metallic sphere. Dependent on the size of sphere, so it is also dependent on the size of sphere because the potential on the surface of sphere is V1, which can be written as Q by C, and C is the, so V1 is equal to Q1 by C, and capacitance of the metallic sphere depends on the size of metallic sphere. So the correct matching for T1 will be P, R and T. Now if I check the entry B, ratio of T2 by T1, since the intensity is same in both the case, so the ratio of T2 by T1 is proportional. So the ratio of T2 by T1 is proportional to the ratio of Q2 by Q1, or I can say that it is proportional to V2 by V1, as C is same in both the case, as C, that is the capacitance of the sphere, is same 4 pi epsilon naught r in both the case. So if I check the options, so it is independent of the intensity I naught because the same intensity is falling on both the metallic sphere. Since the intensity of light in both the case are same, so it is independent of the intensity I naught and it is dependent on the work function phi naught. From the ratio V2 by V1 we can say this. From the ratio V2 by V1 we can say this. So the correct matching for entry B will be Q and R. In entry C, so if I calculate the common potential, then V common can be written as C1, that is C into V1 plus C into V2 divided by C1 plus C2 divided by C1 plus C2, that is 2C. So it is equal to V1 plus V2 by So V common depends upon the work function and it is independent of I naught. So the correct matching will be R and S. Since it is independent of C, so it does not depend on the size of sphere. Let's check for entry D. So the charge transfer Q is equal to C into V1, that is the initial charge on first sphere, minus C into V common, that is the final charge on first sphere. So it can be written as C into V1 minus of V1 plus V2 by 2. So it comes out to be C into V1 minus V2 by 2. So Q and R is the correct matching, and if I check entry T dependent of size of sphere, then it is also correct because Q is proportional to C. So QRT is the correct matching for entry D. So in question number 16, the correct matching for entry A is PRT, in entry B it is QR, in entry C it is QR, and in entry D it is QRT. Let's move to question number 17. In question number 17, in column 1, O represents the point object placed in vicinity of the optical instruments. It is known that image of object is formed on object itself. Distance D between the optical instrument is shown in the diagram. Possibility of value of D for which condition is met is given in column 2. Match the entries in column 1 with column 2. So if I check the first entry of column 1, then object is placed at a distance of 30 cm from the converging lens of focal length 20 cm. So if I calculate the image distance in this case, then 1 upon V can be written as 1 by 20 minus 1 by 30. So on solving, it comes out to be 1 by 60. So the value of V comes out to be plus 60 centimeter. So if I draw the ray diagram, then the rays are falling like this. So since the object is not kept at the focus, so the only possibility left is that it strikes the plane mirror at this point so that it reflect back in this direction. So in this case, this separation D must be equal to 60. So the correct matching for A will be Q. Let's check entry B. In entry B, the object again is at a distance of 30 cm from the converging lens of focal length 20 cm. So the image is formed at a distance of 60 cm from the converging lens. Now there are two possibilities. Either this ray goes to the center of curvature of the convex mirror and gets reflect back because the angle of incidence is 0, then the final image will form at the object itself. So in that case, this separation must be equal to 60. Since this separation is 20, so the value of D is equal to 40. So the correct matching will be R. Now the second possibility is that after refraction from the lens, it strikes the convex mirror in this fashion. Then it gets reflected back in this way, and this will again coincide with the object itself. So in that case, this separation must be equal to 60. So the value of D is equal to 60. So the correct matching of B is Q and R. Let's check the entry C. Now the object is kept at the focus of the converging lens. So the rays gets parallel after passing through this converging lens. And when it reaches to this converging lens, the focal length of this lens is 20 cm. So the only possibility is that the ray goes in this direction, and after reflection it goes in this direction. So the value of D must be equal to 20 cm. So the correct matching for C is T. Let's check the entry D. So in entry D, the object is kept at a distance of 50 cm from the converging lens of focal length 30 cm. So if I calculate the image distance, so it comes out to be 1 by 30 minus 1 by 50. So on solving, the value of V comes out to be plus 75 centimeter. Now there are two possibilities. First possibility is that after refraction from the converging lens, these intersect the concave mirror at this position and then get reflected. So in that case, the value of D must be 75. So the correct matching will be S. And the other possibility is that the ray passes through the center of curvature of the concave mirror in this fashion, and after reflection, because the angle of incidence is 0, it retraces path and finally coincide with the object itself. So in that case, this separation will be 75 and this separation will be 40. So the total separation D will be 150. So the correct matching is also P. So the correct matching for entry D is P and S. So in question number 17, the correct matching of A is Q, of B is QR, of C is T, and of D is PS. Let's move to question number 18.